So, second part of the video now, it says, describe how you'd investigate the resistance of a filament lamp as it changes its voltage. Include your answer, label diagram. Yeah, there it is. How you would obtain a range of results and how would you analyze these results. Well, I'm not going to spend too long on this because this is a standard circuit. I got my ammeter in series. I got my lamp there, which comes from the question. This could also be a diode. It could also be a resistor. It could be anything they ask me, really. It could be a thermistor or a light emitted diode. It could be anything, but they've asked me for a lamp. So I've stuck a lamp, I've stuck a voltmeter across it in parallel, and there's my variable resistor, well, the resistance. So I said, number one, I need to set the VR, variable resistor, to the maximum setting, and that won't allow any current to flow. So I won't get any readings at that point. It'll be 0, 0. Then I'm going to start adjusting the VR, the variable resistor, so it allows a fixed value for voltages through. So fixed values, 0.5, 1, 1.52, etc. So you've got these incremental steps. It could be 0.25, then 0.5, 0.75, 1. It could be up to, it could be 1, 2, 3, 4. So long as they're equal steps, it doesn't matter. Just giving that as an example there. Record the current at these intervals, at these points, at these settings in the table of results. Repeat these adjustments to give a range of voltage current readings, and then you're going to plot these results on a voltage current graph, which is going to be this down here now when I show you. You can also calculate the resistance by using this equation. So that's just from that triangle, VIR, and I've just rearranged that. And I've said, note, if you turn the battery, okay, you're going to get negative values. Now, you don't often see it in these, but see these little graphs down here? You can see that on a resistor, you've got that proportional sort of relationship. And then if I turn the battery, it's going to come down in the negative axes as well. Let me move that up. With the lamp, you're going to get that filament lamp sort of, it's going to, as voltage increases, current is going to increase at a decreasing rate. It's going to start to tail off, and it's going to do the same in the negative axes. But when you're dealing with a diode only allows current through in one direction, so you're not going to get that opposite. You're not going to get those negative readings. So it's just going to be like that. It's going to, at an increasing rate there. And then the next part of the question says, oh, look, here's some results for you. Please plot them. And that's basically what it is. And you can see that they've got their range there. So they've actually gone up in twos. Look, remember I was on about those incremental steps on this point by here? Okay, they've actually gone up in twos there. And they've taken their current readings there. So that's your independent, the thing that you change or the thing that you're choosing, and then the thing you're measuring is the dependent variable. And then I've got to come up with some nice scale for this. So I've gone up in 0.51, 1.52, 2.5. Always goes up in either ones, twos, or fives, and I've chosen fives here, as you can see. Even though what I mean by that is like sort of multiples of 5. And then on the bottom, 2, 4, 6, 8, 10 fit quite nicely. I've used more than half of my graph paper there, and I've got a nice little curve. So you get a mark for that curve as well. And then on this page, which is my last page, it's got use the graph on page an equation from page 2 to calculate the resistance at 5 volts. So at 5 volts, let's have a look what my current is. Okay, at 5 volts, my current is just above 1.5 there. So if each square is worth 0.5 in this case, 0.05. So this is going to be 1.55 at this point, and then it's going to be 1.6 there, 1.65, 1.7, 1.75, 1.8, 1.85, 1.9, 1.95, 2, and just like that. So there's my equation. I've got my IV. So I've written what I know. This is how I love to see it laid out like that. An examiner is going to love to see that laid out like that. And then it's literally voltage over current, which is 5 over 1.55, giving me 3.22 ohms. 3 marks for that. You can't just leave that there. Use the graph to explain how resistance of the lamp changes as voltage increases. Well, there we are. As voltage increases, the current also increases at a decreasing rate. So as voltage increases, the current is also going up, but at a decreasing rate. It's going to start tailing off. Okay, and that's that. That is that paper. So hopefully you've listened and you're going to get something from that.